Okay, well, hi, welcome to a different type of video, I suppose. Now, the reason I'm doing this is because for Year 12, I have to do my lessons live, so I thought I'd test it on Year 10. I guess I should talk about my setup. I'm streaming my iPad to my PC, so that's what you can see on the left there, on the right. On the left, you've got our Google Classroom, which I'll talk about in a sec. My webcam, or face cam, is my phone, so that's kind of interesting. And yeah, I guess that's it. So I guess so far what we've done is we've looked at trigonometry and we've looked at everything you should already know. So that's why I got you to do that topic test, because I wanted to see, I guess, how much people knew, and it was a bit of a refresher anyway. So you had the revision, and then we looked at two newish applications of trig. So the first one being bearings, which is pretty common in the advanced course for them to ask a question in HSC about bearings, just because they're so confusing and involve a picture. And then 3D trigonometry. So again, this is just trigonometry, but just drawing a good picture. And now we're going to move on to more of the advanced stuff. So we're going to move away from, well, not really move away, but we're just going to start talking about trigonometry in a bit of a harder sense. Harder being, I guess, all you guys really know so far about trig is that we're just dealing with triangles, and we've got these three ratios that are just kind of out of the blue, like sine, cosine, and tangent. They're just kind of things that you've accepted. Trigonometric relations, we're just talking about the relationship between each of those. Now, so far, no one's really asked, I guess, what they mean or anything like that, and I feel like this class is pretty good at asking you why certain things are the way they are. But so far, we've just accepted the fact that there are three things called sine, cosine, and tangent, and no one's really told you, I guess, what they mean or why they exist or what even are they. Like, they're just these random functions that spit out a fraction. Like, what even is that? So I guess this lesson's going to give you a bit of a deeper understanding of what trigonometry is, and we'll just go from there. So there's two things I'm going to show you. The first thing is something you already know, but it's going to help us relate the ratios together. So let's just get into it. So the first thing we're looking at is complementary angles. Now I hope that you remember what a complementary angle is. Side note, we have to play hip hop radio, because if I play Spider-Man, then I'm probably going to get a copyright strike and I won't get any audio on this, so there'll be a huge waste of time. Complementary angles. I don't like that being that sick. There you go. Okay. So I guess what I want you to do is think about what a complementary angle actually is. So what are they? They add up to something. You've got supplementary and complementary. Supplementary add up to 180, complementary add up to 90. The way that I remember that is a complement is the right thing to do, right? 90 degrees, I don't know. So they add up to 90 degrees. That's what a complementary angle is. Have a think about this. Sine, and then cosine. That's just the complement of sine. That's actually what that means. So sine is the complement of cosine, and the inverse is true as well. So cosine is the complement of sine. They're the complement of each other. So I guess that's where cosine comes from. Tangent's a little bit different, but there is such thing as cotangent. You won't see that for a while, but it's nice to know that that actually is a thing. Okay, let me draw a triangle. I guess we should start with a triangle. Please draw. That's going to annoy me. That's also going to annoy me. Come on. What is going on? Just draw a right angle triangle. Last attempt. There we go. Okay. If I'm really unneat, it's because my hands are freezing, so sorry about that. Alright, right angle triangle. All we know so far about trigonometry is that we do with right angle triangles, we can find angles, we can find sides, we can do all that sort of stuff, but we haven't really looked at what our ratios mean. That's what we're doing today. So let's name this thing. Let's call this, not names and give it a name. Let's start naming stuff in it. Okay, if this is A, then that's got to be little a, that's got to be little c, and that's got to be little b. I'm going to start writing out some of the ratios. So let's start with, actually, I guess, oops. First thing we should note is this. The angles in here have to add up to 180 degrees. If this is already 90 degrees, what can I say about A and B? I can say that they have to add up to 90 degrees. 90 plus 90 is 180. So the first thing I can say is A plus B has to equal 90 degrees. Now, if I knew what B was, how could I find A? Well, I could just take it from 90, and I guess I can do the same thing for A, 90 minus B. So now I can relate A and B. I'm going to do that a different way. So have a look at, let's suppose I wrote sine A. What is that? Well, A is my angle. Sine is opposite over hypotenuse. So opposite over hypotenuse, so A over C. That's the first one. I'm going to start writing these out. Sine B. So instead of using A as my angle, I'm going to be using B as my angle. So B, again, opposite hypotenuse. So B over C. B over C. This lesson is going to be about identifying things that people might have already seen, and I'm going to try and formalize it. So I hope that some people have noticed this before. Cos A and cos B. So cos A, so adjacent over hypotenuse, so B over C, and cos of B, so that's adjacent over hypotenuse, so that's A over C. A over C. Now, I know for a fact that you've been asked questions like this, where it's like, here's a triangle, tell me what sine A, sine B, cos B are. And then you would have just written a bunch of fractions. In fact, you did this a couple of lessons ago, where it was one of the first questions on that test, and it was broken up like this. And there was like, tell me what sine cos tan is, sine cos tan, sine cos tan. And what you might have noticed, because the triangle looked like this and had x and y in it or something, what you might have noticed is, all the answers are the same. So look at this, sine A and cos B, they're actually the same. And sine B and cos A, they're also the same. That's not a coincidence. So these two are equal to each other, and these two are also equal to each other. So that's not a coincidence at all. And it's got to do with the fact that they are the complement of each other. So I'm going to keep going. Therefore, sine A is equal to cos B. That makes sense, doesn't it? So sine A is equal to cos B. They're both A over C. Now, what we know about B is that it's also 90 minus A. So I know that sine A is equal to cos 90 minus A. And the converse, so sine B is equal to cos A. But I know that sine B is equal to cos B, 90 minus B. So these are actually two very important results. So this, that's really not big enough. This and this, they're quite important results. I'll show you why. No, actually, you probably won't believe me why. Just simply because of this question. Let's suppose, here's my first example. I've got sine 35. That's equal to cos alpha. What's alpha? Before, I guess what you would have done is gone, well, if I want to get alpha by itself, then I need to get rid of the cos. The way that I get rid of the cos is to cos minus 1 of sine 35. That's a little bit weird. That'd probably work. Well, it should work. But this is way easier knowing that these things exist. If I know that sine 35, what was I about to say? I don't know. If I know that I'm starting with sine 35, then what does cos have to be? Well, it's got to be 90 minus this. They have to, these two things have to add up to 90. That's what this is saying. So in other words, this is equal to cos 55. So therefore, alpha is 55. So in other words, if I know sine of something, I already know what cos is. So in other words, if I had this triangle, and then it gave me, I don't know, 25 here, and I was asked to find sine of this or something. If I was asked to find sine of this, that's the same as cos of this. I feel like I confused myself saying that, so sorry. But basically, if I've got sine and cos equal to each other, the two angles have to add up to 90. That's it. So that's because they're the complement of each other. Okay. Question number 2. Let's suppose I've got this. I know that P plus Q is equal to 90. I apologize, this video is going to be a little bit long because I'm writing notes from scratch, but hopefully it's a little bit more in depth. I suppose I know this, and I also know that sine Q is 15 over 17. I want to know what I want to know what cos P is, and I want to know what cos Q is. I'm not really told much at all, but what I am told, this should be a given, like P plus Q is 90. This is basically saying if this was P and that was Q up there, then these add to 90. We should already know that. But if I was given this question, I'd obviously start by drawing a triangle. So let's do that. For God's sakes, why am I so bad at drawing triangles? There we go. Okay, here's my triangle. I'm going to call things P and Q. Those results of a triangle look like this. That must be R, I guess. Now, I'm told that sine Q is this. Now, what you need to keep in mind is this is opposite, and that's hypotenuse. So from Q, my opposite is going to be this. So that's going to be 15. And the hypotenuse needs to be 17. What's cos P? Well, I guess I should figure out what that is. Cos P. So cos is this. Cos is adjacent over hypotenuse. So can you see that I didn't even need to work out what this is in order to get that? So it's going to be, this is simply equal to 15 over 17. So again, it's no coincidence that the opposites are equal to each other. I didn't even need to draw a triangle for the first one. Sine Q and cos P, if I know that they are up to 90, then they have to be the same thing. So it was the same as up here. Sine A cos B, them being the exact same thing. So this is what you would have done previously, and you would have been like, hang on a minute, I ended up with the same thing I started with. This is why. The difficult one is cos Q. Yeah. So for cos Q, I need adjacent over hypotenuse. So that means I need to figure out what this is. Luckily, let's call this X. Actually, it's not called X, it's called QR. QR is equal to, we should be able to do this in one step. It's the square root of 17 squared minus 15 squared. And off the top of my head, that's equal to 8. So therefore, cos Q is equal to 8 over 17. Okay, but that's just showing you that I didn't really need to draw a triangle to be able to do this one. I did for this, which is a little bit annoying, but for this I didn't at all. Okay, let's keep going. So that's the first thing. Complementary angles, I should be able to tell that sine and cosine are the same if it's the different angle, or that they're 90 minus each other. Second thing we're going to look at, should I do a new page? I'll do a new page. Second thing we're going to look at is something called the exact ratios. Now, occasionally, when you work out something like, let's suppose I had sine 30, and you have to type that into the calculator. Occasionally, you're going to get a really nice answer. In this case, this is actually a half. So you might think, who cares, like, whatever. Sine 31, that's not a nice number. I actually have no idea what that is. But there's a few of these ratios that are nice numbers. So I want you to think about, if I did know that, what would cos, actually, what would this have to be for that to be the same thing? I think that's a cool question. I'll leave that there for a second. So most trig things, or most trig I guess, results, so sine something, cos something, tan something, are going to give you some weird fraction or whatever. Now keep in mind this is 0.5. Are going to give you some decimal, and I've always said, you know what, just round your answer to 2 decimal places or whatever it might be, and that's going to give you a length of a side or an angle, or, well, this will give me a length of a side. So far you've just accepted that. What we're going to do now is look at some cases where there's nice results. So a half is the only one where you're going to type something into the calculator, you're going to get a half. Because trigonometry and Pythagoras and stuff kind of works with squares and square roots, some of these results are going to have surds in them, so you might not have noticed these before, or actually probably I don't see why you would have, but yeah, let's just keep going. So I'm going to resort to drawing a perfectly good triangle again. Okay, let's label some stuff again. A, B, C. This is called the special triangle. So the special triangle is a way of identifying the nice results. Okay, it doesn't get more special than, let's call this 1 and let's call this 1. You could call this the unit triangle. The reason people don't is because I'm pretty sure that's not going to be 1. It's going to be the square root of, so if you think about it, it's going to be 1 squared plus 1 squared, 2. So this is going to be the square root of 2. This is a special triangle. Now, generating these isn't too hard. You just got to remember that that's 1 and that's 1. If we were in class, I'd probably be asking, what's this angle going to be, and what's this angle going to be? If you think about it, this is an isosceles triangle. If these two sides are the same, then these two angles need to be the same, and evidently they're going to be 45 degrees each. Okay? Now, let me get rid of this. So this is like triangle number 1. Let's actually call it that. Triangle number 1. The results are as follows. And you might think these are kind of meaningless, and you know what, so far probably you're going to be right, but that's just, anyway. Alright, so I've got sine, cosine, and tangent. It doesn't really matter which one you pick, but I'm going to show you anyway. Let's start with A. So what's sine A, what's cos A, and what's tan A? I don't know why I wrote that, because I know what A is, it's 45. Sine 45, cos 45, tan 45. Okay, sine 45. So this one, I should have written A. I'm looking at A. Okay, A is, sine is opposite over hypotenuse. So it's 1 over root 2. Now, before I even work this out on the triangle, have a think about this. If it's sine 45, what do you reckon cos 45 is going to be? Well, again, these are complementary angles. These both add up to 90, so really it should be the exact same thing. But let's verify that. Cos is adjacent over hypotenuse, so it is 1 over root 2. Tan is, so it's this one, is opposite adjacent, 1 over 1, which is 1. So these three are called exact ratios. Exact meaning that if I were to evaluate this, then it actually gives me an exact result. If I try to evaluate sine 46, that's not an exact result. You're going to get a huge decimal, most likely irrational. Well, actually, definitely irrational. Okay, so let's just get rid of this. So 45 is a special case. So there's actually a bunch of angles that are special. So the special angles being 45. The next one I'm going to show you is, let's call this triangle 2. Triangle 2. What way should we draw this? Let's draw it like this. Please close. Yes. Okay. I don't know why I draw this one smaller. Whatever. So there were our first results. Our second result is going to be this. Let's call this 1, and let's call this 2. What does this need to be? Well, that's going to be the square root. I'll do this in laser. Square root of 2 squared minus 1 squared. So that's a square root of 4 minus 1. So that's a square root of 3. So this side here is the square root of 3. Now, how does that help? Well, I need to think about what each of these angles are going to be here. And I guess there's a way of figuring this out. Let me draw a little bit of a... Let's turn this into an isosceles triangle. So what does that make this side? Well, that makes that side 2. Why did I draw a question mark? That makes that side 2. That makes this 1. Now, this isn't actually an isosceles triangle anymore, is it? Because that's 2, and that's 2. So that means that's 60, 60, and 60. So that means this is 60. This is 60, which means that's 30. Okay. So now what we've got is another special triangle that has the angles 30 and 60 in it. So 45 is not the only special one. There's also 30 and 60. These are like our special ratios. So if you type in sine 30, sine 45, sine 60, or cos or tan or whatever, these are our exact. You can get exact results. Okay, let's try. Sine 30. I said what that was before. Let's do sine 60, cos 60, tan 60. Okay, let's investigate. So sine 30. I said that was a half before. Let's see if that's true. So 30, opposite hypotenuse, a half. Now, let's not even look at the triangle. I'm sure there's more that we can fill out. So cos 30. I don't really know what that is, but I should know what, if sine 30 is this, I should know what cos 90 minus 30 is. So cos 90 minus 30. That's cos 60, which is here. Pretty sure that should be a half as well. Let's verify. Cos 60. 60. Adjacent over hypotenuse. 1 over 2. Nice. This should also tell me that these two are going to be the same. And they are. Let's have a look. Cos 30. So 30. Cos is adjacent over hypotenuse. So it's root 3 on 2. Okay. That must mean... How come it's written like that? Okay, anyway, root 3 on 2. Okay, so these two are the same, and these two are the same, because they're complementary. Tan's a little bit different, but let's still go. So tan 30, 30. Tan is opposite over adjacent, so 1 root 3. 1 root 3. Tan 60 is opposite over adjacent, is root 3 on 1, which is just root 3. Now, all these, please zoom and let me move. So, actually, each of these results are considered our exact ratios. So if you're ever working out a trigonometry question and you're given a question like this, and then it ends up being, okay, tell me what sine 45 is, you should know what that is. Now, when I was doing advanced in high school, we weren't given a reference sheet. So on your reference sheet next year and stuff, you're actually given these two triangles. We weren't given that, so I used to have to try and memorize these. I actually still have to this day on my wall. I'll show you in class, but I made a table that has all these results in it. Yeah, that's, I guess, all up. So, okay, let's answer some questions. We're almost there. We're almost there. 23 minutes. Whoops. Alright. Fine. Okay. Let's go with drawing all my triangles exactly the same. That's not even right angled. Neither is that. Oh well. Pretend that's a right angle. That's 12. That's 60. That's x. Tell me what x is. Well, that's actually something you've done before. A lot. And this would have been in your thing. But have a think about it. Because this is 60, you're going to get a nice result. So what I can do in this case is say, tell me what x is, but I want it to be exact. So the question might be, find x exact. So the way I'm going to do that, let's do the solution in blue. Okay, well, I guess you label your triangle, that's opposite, that's adjacent, so I'm looking at tan. Okay, so tan, I know it's opposite over adjacent, and then I'll fill it in. So tan 60 is x over 12. Okay, then I move the 12 over, so it's 12 tan 60 equals x. And at this point, you would type it into the calculator. But I know what tan 60 is. Tan 60 is root 3. So in other words, I just go 12, this whole thing is just root 3. So that's 12 root 3 is X, and I'm done. So I don't even need to type them into the calculator. But it does, I guess, mean that you need to remember these. Alright, let's try another one. So 2, let's draw the triangle backwards for once. This way. Okay, let's say this is theta, 3, 2, tell me what theta is, but be exact. So find theta exact. Dots. Okay, so label it. This is adjacent, that's hypotenuse, so I'm using cos. So I always just fill it. Let's just do this first. Adjacent at hypotenuse. Okay, now I fill everything in. Cos theta. A is root 3 on 2. Okay, now that I see something like root 3 on 2, I guess what you need to think about is, do any of my answers involve anything like this? And I guess my clue is going to be, if you have a square root of 2 or 3, or half, or 1, like this one, then perhaps you've got something that's exact. If not, just if in doubt. If you did like what you would normally do is go, you know, theta is cos to the minus 1 of root 3 on 2. That's what you normally do. You would get, well, actually, what is it? Cos root 3 on 2. This one. So you'd get 30. So that would equal 30. But I guess what you can realize is, using the table, you just would know that theta equals 30. So I guess for this one, you know, it just saves typing into the calculator, which each of them do. In other words, this lesson is, I say there's nothing really new, because nothing that we did here you would necessarily need to use. But it's just identifying that there are relationships between the trig equations, the trig ratios. They do relate to each other. It's not a coincidence that some of your answers are the same. It's also not a coincidence that sometimes when you end up with surds in your answers, that your angles end up being really nice. I feel like people in this class might appreciate the fact that there's that these relations do exist. So I guess it's just making you aware that these do exist, and we're going to be using results like this to solve equations. That's kind of where we're aiming towards. Yeah, so it is worth, I mean, actually, not what I'm going to do. I'm going to post in the classroom, I'm going to post a photo of what my one looks like. But essentially, it's just got these, and you just have like, okay, sine, cos, tan, 0, 30, 45, 60, and then what they are, basically. Oh, there's one we haven't really looked at. I want you to think about these. I'm not going to do these. I just want you to think about these. What's sine 0? What's cos 0? What's tan 0? And the complement of those. Complement of those being what's sine 90, what's cos 90, and what's tan 90. I want you to think about those. If you're going to make your own table, which I reckon you should, identify what you think they might be. And I guess you can't really draw a triangle where there's an angle of 0 and an angle of 90. That would just be a straight line. But I don't know, have a go. I don't want this video to be too long, even though it already is. But when you think about it, I guess in class I talked for half an hour, so yeah. Anyway, have fun.